top left of the flip book. We'll look at increasing and decreasing first. And the nice thing about both of these concepts is they're relatively simple to describe. What makes it challenging is when we look at the formal definition. Alright, so increasing and decreasing as we move from left to right. This is always true. You always move from the left to the right. We never go backwards. And we'll start with increasing. So what's the simple definition for increasing if we're moving from left to right? Which way does the graph go? It goes up. The graph moves up. That's it. Now, we developed a more formal definition. I'm going to write that for you so you have it. F of x is increasing, and now you understand the different parts of it. On the interval AB. What does AB represent? Your domain. So we'll translate that to our domain. If for x1 and x2, and what do x1 and x2 represent? They're your, not your y values, they're your x values, right? So your 2x values. If for x1 and x2 with, and this is the thing that initially intimidated a lot of you, but you were able to unpack it and figure it out. Actually, I think this one is just, x1 is less than x2. The B for f of x of 1 is less than f of x of 2. Okay? I'm writing very small. I apologize. If you can't read this, it's in front of you on the CPM. I'm just writing the formal definition. We're just unpacking it. I think it's easiest if you actually visualize this with a graph, and a lot of you drew a graph and it made it a lot easier to understand. So this is all this really means. A and B are your domains, your domain. So we can put A here and B here. And then we have an x1 and an x2. And x1 has to be smaller than x2. Which a lot of you guys did on your number line. And the last part of this is f of x of 1. What does f of x mean? Y value at x1 is less than our y value at x2, which you can see now x1 is lower than x2. Which way is my function going? Is it increasing? Yeah, this is just a really, really fancy way of saying it. Okay. Now, there's no way I'm going to do all this again for decreasing, but I do want to show you the one area where decreasing changes. So for decreasing, you only have to change one part of this. And I was talking to a lot of you groups about this. Here's increasing, right? Decreasing, you're only doing this. This is just changing, right? So are we messing with any of the horizontal movement? No, the only thing that changes is the y's. So two different ways to change the y's. What's one of them? Change the sign, which is probably the easiest. Victoria, how would I do that? F of x of 1 is greater than f of x of 2. And now if you looked at it, it would end up going down. They literally just flip. Instead of moving up, it now goes down. Because this point goes on top, and this one now goes on the bottom. Okay. And I should probably put that decreasing moves down. Okay. The other topic is the topic of concavity, and I'll put that on the right side. You should have a little bit of room for it. And concavity is really just how, or actually let's say it this way, the direction the curve opens. And I'll include a picture for this because I think it's easier to see. So let's say here's my XY axis, and let's do almost like a sinusoidal function here. All right, turn to your neighbor. Tell them, is this concave up or down? All right, which way are we going here? Concave up, and this is concave down. Okay. Another way of looking at this, Courtney, she was taking calc. She's in one of my periods now. She was saying Miss Kondo teaches it just either as a happy face, so you can put 2 dots. This is concave up. Or if you put it this way, right? You see the frown? It's concave down. So this might be an easy way to remember it. You can see, oh yeah, I'm smiling, we're going up. Frown, concave down. Okay. So can you have something that's concave up and down? Okay.